Hello, my name is Melita Grant from the Institute for Sustainable Futures at the University of Technology, Sydney. I'll be presenting to you an overview of the Australian WASH Reference Group, and the Australian WASH Reference Group are hosting today's session. But to begin with, I'd like to acknowledge the traditional owners of the lands upon which we all meet and pay my respects to elders past and present. Also like to thank Indigenous Australians for their generous gift of the Uluru Statement from the Heart, which has already been influencing Australian society and foreign policy, and very happy to see the Australian government acknowledge and applaud the Uluru Statement from the Heart and take the next steps towards its implementation. So the Australian WASH Reference Group is more than the sum of the parts, and I'll explain that as to why that is the case. We developed 15 years ago. It was formed in 2007. We started as an informal network of organisations working in WASH in developing countries, but based in Australia. And as of this year, we have 38 members from 27 organisations, and this is made up of non-government organisations, academic institutes, and small-scale private sector organisations primarily working in WASH. And we're led by an executive committee that's made of passionate members from ISF UTS, Plan, Engineers Without Borders, WaterAid, International Water Centre, Live and Learn, Essential Need, Habitat for Humanity, and University of Western Australia. Our overall aims are to improve Australia's response to the global sanitation, hygiene, and water crisis. And we do this by making sure that WASH is a priority for the Australian government and development agencies. We want to see WASH mainstreamed in the Australian government's aid and development program and policies. We want to improve the quality and the quantity of Australia's foreign aid for WASH. And we want to see efforts strengthen around the quality of the WASH work that we, within our organisation, within our network, do. And we do that by being a community of practice and sharing and learning and influencing each other. Our ways of working are around advocacy and around information linkages primarily. So we engage with parliamentarians, we engage with DFAT, and also with the broader WASH sector and international and local organisations. So you can see that we're made up of those types of organisations, and we focus our energies largely on those two elements, the advocacy and the information knowledge sharing. We think this partnership model is important because the collective voices are stronger than our individual voices. We want to see, and we have seen, we've got demonstrated outcomes from our advocacy, our information sharing to strengthen WASH policy and practice. We have got a huge range of skills, strengths and resources across the membership. So we can pull those, draw on them and create change, leveraging those strengths and resources. And we provide DFAT with a direct connection, a one-stop shop, if you will, to enable DFAT to tap into the WASH sector, both in terms of advice and also inputs and talking about strategy. So our plans for this year, we're working on a new government WASH briefing for Minister Penny Wong and also Minister Conroy, and we will be emphasising the importance of WASH in Australia's approach to foreign affairs, aid and diplomacy. And some of our key asks in that brief are around the need for more investment, the quantity of aid spent on WASH is insufficient, that sanitation targets in particular will not be met with current models and current approaches. We need a more coherent and evidence-based WASH and aid and development policy in Australia, that our regional health security cannot be achieved without investment in WASH. And we've seen the importance of WASH during recent pandemics, but especially in our healthcare facilities, in our schools, in places where people go to and need to go to on a daily basis, and their health is impacted if WASH is not provided adequately and safely managed. And then finally, we really want to see WASH elevated as being seen as and understood as a critical ingredient for any response to climate change adaptation, but also mitigation. So just ensuring the importance of WASH within Australia's foreign policy related to climate change. And so we've got some plans this year, some of which we've already completed. We had a climate change learning event in February. We have the WASH Symposium, this one that we're part of today, based on nature-based solutions and bringing our members together to share their experience. We engage in a range of resources and information sharing through the network. We have monthly meetings and regular meetings with DFAT. And we are always planning for longer term advocacy, understanding the changing environment and opportunities for influence. So if you're an organisation that is within those types of organisations, academic, CSOs, small-scale consultancies, and you're interested in joining and being part of this network, please contact myself or John Kelleher. We're the co-chairs of the group for this year. Thank you very much.
Thank you, Melita. Hello, everyone, and thank you for a lovely introduction there, Melita. So, nature-based solutions. Now, this refers broadly to any action to protect, sustainably manage, or restore the natural environment that addresses societal challenges. Distinct from conventional engineering practice, nature-based solutions seeks to jointly address the interconnected vulnerabilities of our natural and socioeconomic systems and to leverage natural advantages to socioeconomic benefit and vice versa. Now, an additional strength of nature-based solutions is that they offer inexpensive options for communities with constrained financial, manufacturing, or human resources when compared to conventional, commonly adopted solutions such as hard flood defences or intensive agricultural systems. Now, for WASH and development practitioners, nature-based solutions represents a practical means to address climate change, natural hazards, and development challenges, while also reversing biodiversity loss and empowering local communities. This session today we're presenting industry's experience, assessments and projects that have demonstrated a positive impact in communities on the ground by providing access to safe water, sanitation and hygiene practices in the climate change context through the use of nature-based solutions or other sustainable approaches. So we want to open the space to explore and discuss this with the help of our audience here today, and thank you all for attending. And we have some key topics that we would like to really raise and discuss through our panel session a bit later on. And that's looking at the value of local expertise, the knowledge and resources to identify, develop and pilot and adopt long-lasting development solutions. We want to look at the value of partnerships across different regions of the world that can conjugate state-of-the-art technical expertise with the local customs, contexts, resources and desires. And finally, the urgency of finding new approaches that can address the critical needs of local communities in a context where climate change exacerbates the growth of social inequalities and vulnerability. So in this session today, just to frame, a series of 4 presentations will be given by experts and practitioners from the conservation, the WASH and the engineering sector, followed by a panel discussion where collectively with questions from yourselves as the audience, our presenters will discuss the integration of different approaches to deliver sustainable WASH solutions to climate change for urban and rural communities. But firstly, before we begin, I have a short video that we'd like to share with you to start to frame the scene for this session. the video was actually a good introduction to our session now. You would have noted at the end that it identified there was 10 key lessons that through the publication that was highlighted in the video at the very end there, that were specific to what needs to be considered when assessing nature-based solution options for wastewater treatment. I've had a review of these and it's a very good publication. And what I've found in reading through that was that many of these key lessons are also systemic considerations for any situation. And so now, as we present our first presenter for today, as we hear from Dr. Emilia Wenger and more from our presenters, we'll start to see some of these key lessons being actually shared through each of their presentations. So now I would like to welcome our first presenter today, which is Dr. Emilia Wenger. Dr. Emilia Wenger is a marine conservation scientist with over a decade of experience working on understanding drivers of land-based sources of water pollution in the marine environment and identifying management strategies to mitigate it. She's an associate conservation scientist with the Wildlife Conservation Society's Global Marine Program and a research fellow at the University of Queensland. She supports Wildlife Conservation Society's global coral reef conservation programs to design, implement and evaluate water pollution interventions that can achieve public and ecosystem health goals. Welcome, Emilia, and we're looking forward to hearing your presentation.
Thank you so much, Leah, and thank you everyone for coming to the panel today. I guess I'll just say next slide when to change it. Does that work best? Move to the next slide. Yeah. So as Leah mentioned, I'm a coral reef scientist, which feels funny to be opening up a panel on WASH. But I thought I would just take a few moments in the beginning of my talk to just go through why, as a coral reef scientist, I'm here and what I think, are the really sort of strengths in the conservation and WASH sectors collaborating. Next slide. I've been working on, as Leah mentioned, on pollution impacts to coral reefs for over a decade. These are some pictures of coral reef flood plumes entering the Great Barrier Reef. Next slide. And as you can see, this is a picture of a coral reef that's been completely smothered by sediment runoff. You see the one lone sort of solid coral there that's dead, and sediment and other pollutants that come down from a range of land use activities, including wastewater discharge and untreated effluent, can kill reefs, can cause algal overgrowth, cause lots of coral disease, and so a lot of science has been working on sort of understanding the impacts of pollution on the marine environment. Next slide. Now, working in Australia, although we sort of considered public health tangentially, considering contaminated fisheries as a result of pollution exposure, I hadn't really worked that closely on the public health. And then in 2015, I had the opportunity to go to Myanmar. This is a village in the southern Myanmar, Langan village. And as you can see here, houses right over the marine environment, there was very little sanitation or water infrastructure to be seen. Next slide. One of the reasons that we were there was to actually do surveys of the coral reefs in what's called a locally managed marine area, which is basically a small community organized marine protected area where the community is managing their resources to have sort of sustainable fisheries. As you can see at the bottom there, it received funding from the EU, funding from Arcadia, so high, large international bodies funding this management of this locally managed marine area. Next slide. So this is a picture of the village looking out. You can see where all the boats are, where the coral reefs were. And so was anticipating seeing a lot of solid waste on the reef. We got into the water and the water was green with the amount of algal overgrowth and algae in the water from all of the nutrient runoff from wastewater. There was coral disease everywhere. The reef was just in really poor shape, very few fish to be seen. And when I finished the dive, I got a full body rash and I had gotten some water in my eye. and I had an eye infection after being in the water for an hour. There was no clean water in the village. I had to wash myself off with bottled water. And it really, not only, obviously, was it very obvious that there were human pathogens in this water, there were children playing in this water, but also made me feel really frustrated that the sort of marine conservation organizations and funding had focused on funding this only marine interventions and had failed to consider any kind of land-based sources of pollution and how that might undermine this locally managed marine area. It was not delivering on the conservation goals that it had set out to achieve because it was just completely inundated with pollution. Next slide. And so we know obviously that there's these public health consequences from poorly managed sanitation on land. There's ecosystem consequences from pollution entering the marine environment. And then there's also health consequences from contaminated water, whether it be contaminated seafood or just exposure to the water. And this is sort of estimated to be about $27 billion in economic losses annually because of direct impacts to humans alone, just from being in contaminated seawater. Next slide. And as I mentioned, at the beginning, marine scientists, we've been focused a lot on understanding the impacts of pollution on coral reefs. Next slide. But really, if we want to mitigate the problem, then our activities and our interventions actually have to happen in collaboration and partnership with the sources of the pollution. We're not going to be able to achieve any kind of conservation goals by only focusing on actions in the marine environment. Next slide. So in 2016, I joined the Wildlife Conservation Society, and it turned out that our Melanesia director, Dr. Stacy Jupiter, who is seen here, had been on a very similar journey to me. She started out as a coral reef scientist. Next slide. And started working for WCS Fiji, she came in to do a project on ecosystem-based management and sort of put together the first ridge to reef management plan. So that meant, considering activities that were happening on land and really linking them to what was happening in the marine environment. And what she found was that although communities were very motivated to implement fisheries management activities, locally managed marine areas, because the link was very, clear between if you manage fisheries well, then you'll have sustainable fishing for many years to come. It was harder to convince people to change land use activities based on downstream impacts to their coral reef resources. Next slide. So a few things happened that was sort of the light bulb moment of this linking between the importance of sort of land-based activities and how this public health and ecosystem health intersection. There were massive floods in Fiji. Over several thousand people were displaced, and there was over 300 million Fijian dollars in damage to infrastructure. Next slide. And what was also starting to show up was that you can see here on the x-axis are the dates, and then the y-axis suspected leptospirosis cases per day, which is a water-related disease. And they also saw similar trends in typhoid, that after these big rainfall or flooding events, they started seeing this increase in water-related diseases. And anecdotally, it seemed like this was happening more frequently in areas that had degraded catchments, that had had a lot of logging activities or other sort of land uses in the area. And so it was with this in mind that a colleague of ours, Aaron Jenkins, started looking at this in more detail and found, as part of his PhD research, that in areas where we had a lot of logging activities, where the riparian vegetation, so the vegetation that sits on rivers, where that was degraded, where there was lots of road crossings on streams, those areas tended to have more outbreaks of water-related diseases than areas where you had more intact ecosystems. Next slide. And what we were seeing in Fiji was also being observed globally. So this paper that came out a few years ago found that upstream watershed condition predicted the children's health in 35 developing countries. So, you know, these patterns were consistent with what we were seeing. When we know now that, you know, protecting forests, we know can protect the natural hydrology. It can ensure that the natural filtration that forests and wetlands, coastal ecosystems remains intact. It keeps pollutants out of water bodies, and it can promote groundwater recharge. Also very important then for preventing emissions and sequestering carbon. And so as a conservation organization, you know, our work on nature-based solutions is primarily on protecting and restoring terrestrial and coastal ecosystems, and trying to find these public health and ecosystem health wins. And so I'll just go into a few details, some examples of where we're doing this work. Next slide. So this is Kolombonga Island and Solomon Islands. And we did a project there several years ago where the community was considering putting in a protected area covering the forest above 400 meters, or sort of one of the last remaining intact montane and cloud forests in the country. And so we looked at what would happen if logging were to go ahead in the forest, and even with, you know, following the logging codes of practice in the area. And what we found was that land clearing extent reached 40%, which was allowed under the logging code of practice. Drinking water standards were exceeded nearly 40% of the time. And since the people on Kolombonga Island rely on the more than 80 streams coming down the forest as their main source of water, this was a really large you know, potential impact that could happen from logging in the area. And we also found that about 25% of their subsistence fishing catch and about 40% of the fish sold at markets were going to be negatively affected by logging. So again, you know, protection of the forest was going to achieve these public health wins, protecting drinking water, and also protecting downstream fisheries resources. And this information was then used to sort of help galvanize next slide. When we communicated this back to managers and decision makers, the work helped to galvanize members of various landholder groups and chiefs in Kolombonga. And there's now been an endorsement to move forward with the creation of the protected area. And we're working with local landholders to sort of secure conservation deeds or sort of financing to ensure that the forests can remain protected, but that communities aren't going to be impacted through loss of economic activities. Next slide. And so I guess a lot of this work that we've been doing was building towards this project that's happening in Fiji now, the Watershed Interventions for Systems Health, or WISH Fiji. Next slide. The goals of the project, as you can see, is to reduce the incidence of water-related diseases in both people and coral reefs. It's to empower communities to access their rights to clean water, to strengthen connections to place, develop mechanisms for systems health governance, and then facilitating approaches to sustainably finance and scale these interventions nationally. And this project is done in collaboration with Bloomberg Philanthropies and DFAT. In partnership with several Australian and Fijian organizations and universities. Next slide. And one of the sort of key aspects of the work that WCS is doing and of the WISH Fiji project more generally is this idea of nested scales of interventions to maximize efficiencies to be gained by acting on risks to human and ecosystem health at multiple scales. So we have the global scale, obviously, climate change, which has to be negotiated and solved at a global level. So participating in climate negotiations to reduce emissions. Then there's the landscape scale, and this is where I think, as I'll touch on later, conservation organizations can really excel and be really good partners on the ground. It's around forest protection, soil conservation, ecosystem restoration activities. And then looking at sort of residential activities, individual activities, and then down to things like boosting immunity through vaccinations and supporting good nutrition. Next slide. So in order to communicate these watershed risks at various scales, we've worked with an NGO called Sea Change, who specializes in environmental messaging for behavior change. So we've looked at, how we use the land and how is that causing issues. Next slide. How poor hygiene and sanitation practices and habits can affect our health. Next slide. And then looking at, messaging designed to help local communities understand the range of options that are available to better management of their watersheds for environmental and public health outcomes. Next slide. The project's then been walking through a step-by-step participatory process within each community to develop a water and sanitation safety plan, where different priorities for management are identified. So some of these are nature-based, including protecting areas of forest, restoring habitats, especially riparian vegetation, planting vetiver grass to stabilize soils. Next slide. But it's also through putting in some, more, traditional sanitation and wash infrastructure, including this water reservoir. And we're now scaling this work up across Fiji, Solomon Islands, and Papua New Guinea. Next slide. So I guess just some parting thoughts. As I mentioned throughout the talk, I think the fields of conservation and WASH would make a really natural partnership because we have complementary goals and we can both bring to the table our expertise on interventions at different scales. So I'm really looking forward to the discussion that follows these presentations. Next slide. So just thank you very much for coming to hear this, and yeah, I'll take any questions at the end. Thanks.
Thank you so much, Emilia. It's really fantastic to hear of all the great work that's underway and those connections that you've made between conservation, environmental health, and public health. And I'm sure we'll have a lot more to discuss with you in the panel session on that. So thank you very much. I'm seamlessly taking over facilitation from Leah and Melita. My name's Bronwyn Powell. I'm a water and WASH specialist and also a member of the WASH reference group. I'm a senior project manager at the International Water Centre at Griffith University and also the team leader of the Asian Development Bank Pacific WASH Technical Assistance. It's my pleasure to introduce the next speaker. The next speaker is Ed Rowe from Arup. He's a disaster risk and resilience specialist. So Ed is a chartered engineer with a background in coastal and maritime management, design and strategy, and has more recently led work in assessing and planning for natural hazards and associated impacts of climate change. Ed's passionate about the regeneration of our environment and particularly tying engineering solutions with nature to generate biodiversity and social co-benefit outcomes. Ed has largely consulted in engineering and technical advisory services, but has also worked for a startup social business and not-for-profit in the developing world. Ed will present today on the multi-hazard climate and disaster risk assessment commissioned by Tonga government and the Asian Development Bank in 2020. Over to you, Ed. Thanks.
Thanks, Bronwyn. Hi, everyone. Great to be presenting today. And as Bronwyn mentioned, I'm going to be presenting on a specific project that I was the assistant team leader for that we delivered, Arup delivered with the Asian Development Bank and the government of Tonga, the climate and multi-hazard disaster risk assessment for Tonga Tapu, the main island in Tonga. I guess it was a very technical project that had very defined outputs to define baseline data to then inform future resilience investment for Tonga, and I'll head into a little more of that. Next slide, please. Just an outline of my presentation. I'll talk about the Tongan context, overview of the approach we took to deliver the project, and you can see that that goes through hazard, exposure, vulnerability, and risk, which is a typical risk assessment equation. The key findings of the project and what that all means. Next slide, please. So the Tongan context, the island in the top left, that is Tongatapu, the main island of Tonga. And you can see below there sort of a bird's eye view of Nuku'alofa, the capital of Tongatapu. In the bottom right, you can see a tiny marker out in the Pacific, and that's the location of Tonga relative to Australia and PNG and New Zealand that you can see in Google Earth there. Nuku'alofa, the main city, it's mostly around 2 meters above current sea level. So not very elevated, and as a result, vulnerable to sea level rise, coastal inundation, and tsunami, but also from pluvial flooding due to rainfall, due to the flat topography and the limestone earth. It's estimated there's around 20,000 people regularly affected by flooding in Tonga. And that vulnerability is set to increase due to climate change, due to sea level rise, but also a high confidence that pluvial rainfall flooding will increase in the region. The wider island around Nuku'alofa actually has higher topography, so down on the southern coastland, and you'll see, if you can see me and the picture that's in my background, that's actually the southern coast of Tongatapu, and you can see that there's some elevated lands in the background there. So it gets up to around 12 meters of elevation down the bottom there. So why is there less population on the southern shoreline if that's higher? Well, it was because, like most countries, the city of Nuku'alofa was developed around the port, which is low-lying, fantastic for port operations, not so great for populations living in those low areas. Next slide, please. So a quick overview of the project. I'm not going to go through all of this, but the Tongan government, the ADB was supporting the Tongan government to manage current inundation risk and increase the resilience of the Nuku'alofa urban area. A climate and disaster resilient urban development strategy and investment plan is currently being commissioned, and this work, the project delivered under this project, will inform that strategy and investment plan that will be a long-term adaptation pathway for Nuku'alofa. Down the bottom there, you can see the methodology, and this is a typical risk assessment equation. So you have your hazards, and we undertook a hazard assessment. We undertook an exposure assessment, and developed an exposure database. And then we then looked at the vulnerability of the assets in the exposure database to quantify the risk to all of these assets to the relevant natural hazards. Next slide, please. So to start with, hazards. So as I mentioned, we looked at coastal inundation, pluvial flooding, tsunami, wind and seismic hazards, and these were all assessed probabilistically. And the results of the hazard assessment, including mapped outputs for a range of different return period probabilistic events, such as that you can see in the GIS viewer in the bottom there. We also then developed a range of other events in the background that weren't published that then went on to inform the risk assessment. To further inform the hazard assessments, we looked at some of the influences of climate change and some future scenarios. So what the sea level will look like into the future and how rainfall may increase into the future. And those scenarios were also assessed. And this resulted in around 220 published mapped hazard scenarios that are included in the piece of work. Next slide. This is just a quick example of some of the ways that we provided the outputs of the assessment to compare the different events. So on the y-axis going down, is increases in sea level scenarios, and going from left to right are different return periods. So you have your pluvial flooding only in the left-hand column, a coastal inundation only assessed in the middle column, and combined pluvial and coastal flooding in the right column. So you can start looking at, how are the different hazards affecting different areas and parts of the of Tongatapu and Nuku'alofa, and start sort of coming towards some assertions about what this all means for the city area. You can see that with 2 meters of sea level rise in the bottom row, that there's significant inundation demonstrated by the darker blue demonstrated down there at the bottom, which is actually where Nuku'alofa is located. Next slide, please. Another, so this is looking at specific pluvial hazards. And as this is just another way that we presented the data, and as you go from left to right, the magnitude of the event or the intensity of the pluvial flooding increases, and you can see the changes that occur from left to right. And as you go down the page, there's increased sea level, and you can see the increase in inundation due to the influence of sea level rise. So just another way to present the data. And I guess just reiterating again that this project was focused on creating this baseline data to inform future decisions. So it was very technical in a sense. Next slide, please. So the next step in the hazard equation is exposure. So we pulled together a database of buildings, roads, power, and water assets, and you can see some of the data that was compiled over 30,000 buildings, 250 kilometres of roads, numerous power assets, and numerous water assets as well. And this involved extensive engagement with the different ministries across the government of Tonga, as well as some site investigations. Next slide, please. So as I said, we did some site investigations and developed further data through with a team of local engineers. We used a range of digital mapping tools to map all these buildings, and then looked at the different typologies of the buildings, the roads, and so forth. And you can see there's an example of the different typologies on the bottom right there. That demonstrates that timber frame buildings, for example, were the most common typology of building seen, but this is the way that we just started categorizing all the different assets. Next slide, please. I thought I'd focus on water as well. So we engaged with both the water utility in Tonga and also the Ministry of Land and Natural Resources, who are responsible for water assets in the more regional communities in Tongatapu. And you can see there that these were mapped accordingly. Next slide. So combining, we then undertook an exposure assessment. So combining all the assets that were mapped, we then overlaid the hazards that were assessed in the previous step. And at every asset, we were then able to ascertain the intensity of each hazard. So for example, for pluvial flooding or rainfall flooding and sea level rise, at each of the assets that are mapped in the maps shown here, you can see that the intensity of the hazard has been established at every asset. So whether it's 0.2 meters, which is blue, through to around 2 meters of inundation demonstrated by the yellow and higher, but beyond yellow. Next slide. I might just skip this slide because it's a bit data heavy, and I realize we're a little short on time. So I'll go straight to vulnerabilities, the next part of the risk equation. So this looks at how each of the asset types, a relationship is established between each asset type and each of the hazards. And this, in the very simple example there, you can see that a building that is on stilts is obviously less vulnerable to flooding risk than a building that is at ground level. So there will be a different damage relationship for those two types of buildings. Next slide, please. And you can see this here. So the example vulnerability curve shows for a building that is at ground level, there is a quicker rise to damage than a building that is on stilts and above ground level, which has a slower rise to complete damage with flood depth. Next slide, please. Yeah, thank you. So what is this? What this then turned into our risk assessment, and basically we then combined what damage looked like for each of the different assets, what that looked like in a financial sense, and estimated what financial loss would look like for each of the different hazard scenarios. By assessing all the different hazard scenarios probabilistically, we were also then able to come up with an estimate of annual average loss, which you can see in the bottom row there, that provided an average estimate of loss, financial loss every year for Tongatapu for the relevant hazards. So, for example, under pluvial flood there, you can see that there's about 300 million worth of financial loss, and that's in the local currency every year on average, to rebuild damages associated with pluvial flood across all sectors. Next slide, please. So this, we were able to ascertain that a few different things from this assessment. And as I said, the purpose of this project was not to come up with a whole range of next steps, but instead it was to come up with a database of information that could then inform planning and the next steps for the Tongan government. But regardless, just by looking at the outputs of the risk assessment, we were able to understand that pluvial flood was the most impactful for annual average loss at shorter return periods and at shorter return periods and more frequent events. So this was quite an interesting observation that because of the flat topography, pluvial flooding was very common across the island, and this resulted in a lot of small damage at higher frequencies than some of the other hazards. Wind and seismic hazards, on the other hand, resulted in far greater loss for the higher magnitude events. Whereas for the lower magnitude events, they actually had far less loss than the other hazards. Sea level rise was obviously a big impact, and this would result in permanent losses. So that once the sea level rise and impacted different parts of the land, then these parts of the land or buildings or assets in these areas were assumed to be not re-established in these areas, but have to be moved. And buildings across all the different asset types were the big driver for financial losses. And this was because there were far more buildings than water assets, for example, or for power assets. And as a result, these were driving the financial losses. I might just skip to the next slide there. So what did this all mean? As I said, this was a really technical project delivery that was about establishing baseline data and information that could then inform the next steps for resilience investment for Tonga. So already, you would have seen Tonga in the news after the volcano eruption in the Ha'apai Islands, which are just north of Tongatapu, and the resulting tsunami inflicted damage on Tongatapu. And the outputs of this work were able to inform where that damage would be likely to occur, to inform disaster recovery, which was great. Well, a terrible situation, but a good timing in terms of having data at hand. A new bridge has been proposed for Tongatapu, and this the outputs of this assessment were able to inform how that would look like, how that investment would look like in terms of managing future disaster risk management across the island. And as I said, the ultimate purpose of this project and generating all this data will be to inform a climate and disaster resilient urban development strategy and investment plan that the ADB, the Asian Development Bank, will be delivering with the government of Tonga, and that's currently being commissioned. This will include a long-term adaptation pathway for Nuku'alofa, which will enable continued development of the city in a manner that is resilient to natural hazards. Next slide, please. That was it. So yeah, looking forward to jumping on the panel later and fielding any questions relevant to the project. Otherwise, feel free to reach out to me separately.
Thank you so much, Ed, for that really fascinating presentation, and I guess looking at the risks under different climate scenarios for Tonga. There are a number of questions for you in the chat. It'd be great if maybe you can respond to them in a written form now before the panel session. If there are ones that need discussion later, we can do that as well. But let me move to the next presentation. Very happy to be able to introduce Kerry Burge and Emilia Dallason. Both are project managers on the Revitalising Informal Settlements and Their Environments, or the RISE project at Monash University. Kerry Burge is a water-sensitive urban design practitioner and a project manager, the RISE, for Indonesia. She has many years' experience in the design of green technologies and the implementation of nature-based solutions using an inclusive participatory approach. Kerry is passionate about a water-sensitive approach and its potential to change the way we plan and build cities and towns. Emilia Dallason, who they'll be presenting together. Emily is managing the Fiji side of the RISE project, and she's deeply curious about people and place, which has led her to study and work at the intersection of engineering and other sectors. She's studied environmental engineering, but has woven a career through flood modelling, integrated water planning, grassroots community climate resilience, civil engineering, and decentralised wastewater treatment, which has taken her across the Pacific to Fiji, New Zealand, and Australia. In her work with RISE, Emily has embraced the opportunity to think creatively, build strong interpersonal relationships across borders, and explore how communities can influence and interact with infrastructure and design. Thanks very much, Emily and Kerry. Over to you.
Hi, I'm Emily, and Kerry will be speaking also on nature-based solutions in the context of the RISE project in Indonesia, and I'll be talking about Fiji. Next slide, please. I selected these quotes as I feel like they represent some of the values that drives the RISE approach. So I'm just going to put them up there on screen. I'm going to talk through the challenges and pathways that we found navigating through the approvals process for construction of our infrastructure in Fiji. Next slide, please. So a bit of a background. I'm the project manager for the build aspects of the RISE project. This covers design and construction of green infrastructure in informal settlements, which supports our wider research project. So we have a huge assessment side of RISE. We have one demonstration site, which is under construction at the moment, and 6 further sites that form the case locations in the Action Research Project. We're undertaking the design of all infrastructure, approvals, and construction oversight in-house. Our infrastructure includes wetlands for blackwater treatment, greywater management, access, and drainage. You'll hear more about the infrastructure from Kerry, or equally, you can get in touch with either of us later. But for now, I'll talk about how we got approval to build and operate these systems in people's back gardens. Next slide, please. So I'm going to frame this in the context of 3 big challenges with getting approval. The first 2 kind of link in with each other. One is the not development. RISE infrastructure is not development, it's upgrading. And we work within informal residency. There was no application process for upgrading development in informal settlements. This meant that our initial application was classed as a full development or subdivision application. This led to 12 months of delay as our application couldn't comply with any of the conditions, or many of the conditions, sorry, including demolishing existing structures, raising new ground levels to 2.5 metres above mean sea level, expensive permitting fees, and long processing times that could be upwards of 10 years. There was also the issue of tenureship. Informal settlements in Fiji don't sit on titled land. Next slide, please. In contrast, RISE infrastructure and upgrading is more acupunctural, fitting in with the existing buildings and land uses to provide increased health and wellbeing benefits to the community. We're operating on short timelines, around 4 years from concept to construction, and we're focusing on sanitation works. So a development approach wouldn't work for us either. Next slide, please. I've just put up a quick summary of some of the major stakeholders to make sense of the following processes that I'm going to talk through. These include government ministries in dark blue, landowners, which includes the Itoke Land Trust Board and the Ministry of Lands, Indigenous, that's the Indigenous landowner, is the Itoke Land Trust Board, service providers in green, and regulatory bodies that include the light blue Central Board of Health. Next slide, please. After a lengthy engagement with the Ministry of Housing, Super City Council and numerous ministries, we were offered a new pathway from subdivision to lodging under tenancy at will for sanitation works and settlement upgrading. So tenancy at will is usually granted for individuals and has not been granted, as far as I know, for communities or organisations before. It's an annual approval process that requires permission from the landowner and grants recognition of the tenants as formal residents for 12 months. To proceed, we still needed to coordinate with a lot of stakeholders, getting no objection letters from landowners and service providers, demonstrating our relationships with the community and obtaining consent from town and country planning where there were existing land use zones. This process has taken another 12 months, delayed in part due to COVID, but also as this process is being created as we talk and meet with different stakeholders. This requires back and forth between us and them, but also between the stakeholders. The councils we've worked with have gone to the Ministry of Housing, who grants tenancy at will, but have also required conversation with the Ministry of Lands, the landowner. Depending on the municipal council, this process is slightly varied, where some councils have their own town and country planning representatives in-house. They can process the build permit internally. Others who do not have to go to the Ministry of or Department of Town and Country Planning to provide formal approval. It's also important to note that, as I mentioned, tenancy at will is granted on an annual basis, meaning that it doesn't provide a lot of security for RISE or the residents in the informal settlements. Effectively, the landowner could choose not to renew it and move everyone off site in 1 year. RISE is working with the Ministry of Housing to secure longer agreements for tenancy at will to increase security for the project, but also for the residents. Next slide. So some of these are really straightforward, and but they're part of our learnings, and I think it's important to reiterate them and respect these processes. So how do we get there? It's who you know. It's always who you know. We built a lot of critical relationships, and that came through a lot of our staff in Fiji having really good connections. And one particular example, I guess I can offer on this is one of our settlements got subdivision approval for a plan submitted by the Ministry of Housing to the Super City Council prior to RISE engagement. The implications of this are that many houses in the settlement would be demolished, a new road and lots would be created. The council was hesitant to approve RISE, concerned that it was a conflict of interest with the subdivision. With support from the Ministry of Housing and Ministry of Lands, the landowner, RISE was able to advocate for approval of the intervention works. And while subdivision may still occur, it will be unlikely to occur soon, and the residents will be connected to a formal recognised sewer in the meantime. Find a champion. Throughout, there have been a number of people across government who've really supported RISE. We've fostered those relationships, and they continue to provide support and connections in navigating unfamiliar processes. Repetition. Your ideas and designs are familiar to you, but change takes time. It took us 12 months for the demonstration site, and it continued to take another 12 months for the rest. Over such a long time, the people in decision-making roles sometimes change. And as it became clear what we were trying to achieve, the process also sometimes changed. We had to adapt to that. Governments are big. It's the same everywhere. The added complexity is that governments will not always have a process for your pathway, and this is not always well established. This can be both a challenge and an opportunity. So where you can find a way through using effective engagement. The Fijian government has shown incredible support and encouragement for working with RISE and increasing the wellbeing for the people in informal settlements. Do your research, know your planning requirements if you can find them out, and don't say something wrong that could set you back. Open doors. I guess the biggest advice on that is don't always question it too much. Sometimes if the door has been open for you, even if you don't fully understand, take it, figure it out. Be adaptable with your design, but also how you present to people and also how you frame your story. Different people have different priorities, so be ready to incorporate that into your presentation. Finally, rushing is the antithesis to success. goes back to long repeated conversations. Approvals on paper, they're on paper and people put their names to it. So they're unlikely to approve something that they don't understand or have a system for. So it's on you or us to invest the time. And that's hard in funded projects, but you need to make that shift or budget for that shift. Next slide, please. So that walks through the planning and building permissions. But how do we gain permission to treat sewage in the back garden? We were required to present a proof of concept to the Central Board of Health and the Ministry of Health. We used tools to communicate this, including a description of approach document that we later published as knowledge products, which is available for general public. Context is key. And whilst we were required to provide evidence that the system was effective, a paper story indicating prior examples was enough. It wasn't easy, but it was relatively straightforward. And that's somewhat surprising for MBS. So why? Next slide, please. And this is a bit of a hot take. These systems are not new. My colleague in Fiji reflected that our design jogged memories of their own kitchen waste systems, which were drums filled with gravel set in the ground. Kitchen wastewater would be poured into these drums and provided a similar result to our biofilters in subsurface wetlands. I think there was greater support of MBS as there's a more recent memory of natural systems for many people who are in urban areas and decision-making positions that enables a greater trust for them to perform than perhaps in countries like Australia. Next slide. I can't wrap this up without mentioning the foundation of support that we have in our communities. This has been to the credit of our team and the engagement of communities in RISE throughout the hard, slow, boring times and the free food fund meeting times. They've identified free space on which we can build infrastructure and have aided our applications to government, working with us to make this project feasible. It's a two-way relationship where RISE is working to improve tenureship and health and wellbeing, but they're also engaging with us so that we have greater proofs for implementing this in other locations. The main takeaway from this is don't look at your communities as passive recipients. They not only have the power to make or break your project, but they bring skills, strength, and support that contribute to the reimagining. You must include them as active participants to succeed, and you should include them to learn. I will now hand over to Kerry to talk more about Indonesia.
All right, thanks. Thanks, Emily. As Emily mentioned, I will talk a little bit about some of the lessons from the delivery of our demonstration site in Makassar in Indonesia. In 2018, I had the chance to share our early ideas about the RISE program work at the WASH Futures Conference in Brisbane. So I thought it would be a nice opportunity today to share a little bit about what we've done since then and some of the lessons that we've learned. Next slide, thanks. So we, in late 2017 and early 2018, we did a series of co-design workshops with the community in our demonstration site. Throughout 2018, we continued to undertake design work, and each iteration involved resident input and then consulting experts on what were the non-negotiables in terms of design to ensure that the infrastructure continued to perform and what could be modified to suit community preferences. And that was particularly in relation to the nature-based solutions. In 2019, we completed construction. By the beginning of 2020, we were ready for commissioning, but decided to make a minor change first because we wanted to trial a different waterproofing agent for the subsurface wetlands. We finished that work on the 10th of March, 2020, and we all know what happened after that. So we shortly after all went into lockdown and worked from home. By November 2020, we were able to commission the system using a hybrid model. So we had a team on the ground with very strict COVID protocols and a team on Zoom providing technical support. Throughout 2021, we have undertaken some rectification works and monitored the water quality performance. And now in 2022, we're setting up the RISE, some additional equipment at the RISE lab at the University of Hasanuddin to do further water quality monitoring. Next slide, thanks. So some quick stats on the demonstration site. It's a small settlement of around 22 plots of land. It's fairly typical for informal settlements in Makassar. This one is subject to quite serious flood inundation in the wet season. The sanitation is rudimentary and the water availability was variable across households. Our intervention included new toilets where households did not currently have a toilet or wasn't able to be connected to the system, a pressure sewer system and smart controllers, constructed wetlands for wastewater treatment, improved drainage, a raised access path, and advocacy for municipal water supply connection. So what have we learned since 2018? Some of the key takeaways are that the small-scale demonstration of the approach is crucial for adapting nature-based solutions to a given context. So that includes adapting it to the local culture, the climate, local construction materials, and construction methods. While nature-based solutions are relatively simple in their operation and the design compared to traditional wastewater treatment plants, for example, nature-based solutions do have some specific design requirements that must be satisfied in order to ensure that they meet their treatment performance. So that includes things like waterproofing, plant species selection, and finding appropriate planting material. So we found that the standard methods for construction for manholes, for example, didn't provide sufficient waterproofing for the gravity sewer. So we've been working on a new design for those inspection pits. We also found that appropriate media for the subsurface wetland was really difficult to source. And so we've adapted the specifications to use a combination of quarry, rock, and river gravel. And we're now exploring the possible use of clay balls as a more sustainable alternative. Next slide, thanks. So it's been really important with our demonstration site that it's provided the opportunity to show we can meet the expected performance standards in terms of water quality treatment. Because nature-based solutions aren't mainstream at the moment, it's been really important to be able to demonstrate to regulators, government approval authorities, and other stakeholders that these systems can meet the performance standards for that given context, in this case, in an urban informal settlement in Makassar. But I should say proving this has not been without its challenges. So we've had quite a challenge to find external laboratories with sufficient capacity to undertake the testing requirements to demonstrate the wetland performance. Next slide, thanks. So the demonstration site has also been incredibly valuable for socialising the approach and building an understanding and trust of nature-based solutions amongst various stakeholders. And so we've hosted delegations from national and local governments, representatives from other informal settlement upgrading programs, and representatives from other parts of the region and the country. So nothing really compares to being able to see it with your own eyes. And this has been incredibly important for building support for these nature-based solutions within this context. Next slide, thanks. So as Emily mentioned already, our participatory approach has been at the heart of our success. We developed an approach where residents are partners in planning and decision-making, and it makes the systems more resilient and greatly increases buy-in. We know that it must be a diverse participatory approach, and our research is suggesting that is showing that focusing on diversity within participation increases the success of GEDSI outcomes. The participatory approach, that is including everyone, is important in data-poor areas as well in relation to design. So in the demonstration site, there was only one resident that had been living in that area for long enough to know that floods had occurred over the height of the canal road, and they reported it only happened once, but it did inform the design. And in the last 2 years, with quite strong La Nina, that's happened 6 times. That was really important to get that design right. Next slide, thank you. So we've also learned about the cost to construct these systems. They're comparable to a traditional network solution. So for example, with centralized sanitation on a per household connection basis, but with additional benefits. Sorry, could you just go back one slide? Thank you, thanks. It's really important that nature-based solutions aren't necessarily seen as the cheap option, but one of a suite of alternatives to provide basic urban services that can also deliver multiple benefits, can be delivered at multiple scales. They can fit into reasonably constrained sites, can be delivered on relatively short timescales, and deliver broader benefits when co-delivered together with other infrastructure. For example, increasing flood resilience by co-delivering a raised road together with the wetland. Next slide, thanks. So one of the other lessons we've learned through this process is that combining traditional grey infrastructure with green infrastructure and smart technologies can be a real game changer, or certainly has been for us. The use of green infrastructure has allowed us to deliver a community scale sanitation system that delivers similar treatment and performance to a traditional wastewater treatment plant. Combining it with traditional grey infrastructure has provided improved drainage and increased flood resilience. But the inclusion of smart technology has made the system much more robust. It's improved our troubleshooting ability. It's not using new technology. It's quite well developed and has been used here in Melbourne for 2 decades now. But it's simple and robust, and it really has helped us understand where the weaknesses are and improve them. Next slide, thanks. So nature-based solutions as part of a broader water-sensitive approach can improve flood resilience, diversify water supply sources, improve drainage, protect downstream environments, and can harness existing social capital within communities. This can make communities more climate resilient, and if delivered at scale, can make cities more climate resilient. And just one last slide. So I've got the privilege of presenting here today, but of course this certainly has been a team effort. And I just wanted to take the opportunity to thank my colleagues based in Macassar, all who've played a critical role in the contextualisation and delivery of nature-based solutions as part of RISE. Thank you.
Thank you so much, Kerry and Emily, for that overview of the water-sensitive design, urban design, and also wastewater treatment systems that are being piloted in Fiji and Indonesia through RISE. It's great to get that overview. We will keep moving along. It's now my pleasure to introduce Marinay Cheng, who is the Technology Development Lead for Engineers Without Borders in Cambodia. Marinay graduated with a Bachelor of Engineering in the field of water resources and rural infrastructure in 2017, and has a master's degree in environmental engineering. Currently, she's working with EWB Australia in Cambodia and is also working in the wash sector. She has experience working on water supply and sanitation in challenging environments and developing appropriate technologies for rural communities in Cambodia. Thank you, Marinay. Over to you.
Hello, everyone, and thank you, Brownville. My name is Marini, a Technology Development Project Lead from Engineers Without Borders Australia, based in Cambodia. Today is a great honor to present about the Water and Reefs Future Symposium. So this is the project of rehabilitation of rural water supply adapt to climate change that has been constructed in the remote island in Cambodia. As you can see at the left-hand side is the buffalo. They are enjoying in bathing in the water source, and the right-hand side is our water supply system. Next slide, please. And before we go into the detail of a water supply project, I would like to present about the climate condition in Cambodia. Cambodia is located in South Asia, which is one of the tropical area that is hot all year round with the temperature from 21 to 35 degrees C. And typically, Cambodia have 2 seasons, rainy and dry season. You can see the climate index In the picture on the left, present about the rainfall coverage during the rainy season that affected to almost the whole country, that would cause flooding in some area along the Dallason Lake and Mekong River, while the dry season is significantly hot, that would cause water shortage and drought. Cambodia is considered as the most vulnerable country affected by climate change among Southeast Asia alongside the Philippines. So nearly all the provinces are affected by climate change, result in clean water shortage, extreme flooding, seasonal flooding, water scare, and drought. And climate change also had a major impact on water levels, water quality, and other ecology in the river. Next slide, please. So to adapt and mitigate the major impact caused by climate change, the Cambodian Rural Development Team, who are our partner, and also Cambodian local NGO, installed a rural water supply in Sambo district in Karachi province in Cambodia in 2016, which pumped the water through the network of PVC pipe. Unfortunately, subsequent monitoring showed that only 16 out of 839 target households in the 3 communities were using the water system. So hoping to understand the problem in more depth, in 2019, EWB Solution for Sustainable Development Intensive Team conducted a review of the technical issue with water supply system. And there were many technical issues have been identified and need to rehabilitate the water supply system in this community. Next, please. And this project also, in order to repair and rehabilitate the water supply system, we also apply for the grant to UNDP, and we revert the grant from UNDP to rehabilitate and improve our water supply infrastructure. And we also receive the grant funding from ANCP to operate and implementing the project as well. Next, please. In this project, we are in partnership with local NGO that we call Cambodian Rural Development Team, who is coordinate and mobilize in the community, and also they have the good community engagement in Karachi province, because this partner located and based in the site location that we install the water supply system. And we also got the technical support from Oregon team to design the water treatment plan. And the last one is Severe Consultant, who provide the training on how to identify the customer and develop the water business plan. Next, please. So the community that our team have been working with is in the remote island that we call the village name Kotnaut. Ko, it means that island. And to travel from Phnom Penh office, which is the capital city in Cambodia, to the community require considerable journey. And traveling between Phnom Penh city to the province take time about 6 hours by car. And they are between Karachi province to the district, Sambo district is further hour. And from the district to our target area, Kotnaut Island, is about 40 minutes. In addition, waiting for the boat and travel by ferry to across the river. So it seems like our area is a bit far from the city. Next, please. As you can see, here is my team and I, no doubt grateful to be on the last leg of our journey to rehabilitate the water supply system on the island. Next, please. So regarding to the geography of the target area, Kotnaut is an island surrounded by tributary of Mekong River and several islands. The population living on the island in 2020 is 172 families, equal 128 households, that they are living in the scattering condition and relying on the nature and traditional way. 90% of the population are in the indigenous people, and their occupation mostly are farmer and fishermen. Next, please. Regarding to the water and sanitation challenging, people there are facing many problems. They struggle to access to the water, especially during the dry season, when the river bank is a wide slope and steep. So they need to pump the water from the river by using the diesel or petrol generator. And I saw mostly women collect the water from the river for their home consumption and also for drinking. And they have to go to the river bank to carry the water by their hand. Moreover, besides using the water for drinking and consumption, people need water for small-scale irrigation and raising the livestock. So using a diesel engine water pump is not a good deal because they have to spend money, time, and also pollute the environment. Next, please. Back to the existing water supply, the community there doesn't have the grid line as it located on the island, so it's hard to connect the grid line from the mainland. So we have to use the solar power system to power and to generate the water supply system to pump the water from the river. Unfortunately, the capacity of the solar power was not sufficient to operate or power to the water pump, and the water tank usually broken as well. Next, please. And the distribution pipe network were also broken and leaked since they used the low quality of PVC pipe, and the motor pump were not working well, which caused the lack of water availability for distribution and consumption. At the same time, the water supply control and managed by community were not effective because they have own commitment to do other works, and they have some conflict of interest issue in the community as well. Next, please. So after we identify those issues from the site assessment and observation with our partner, we have changed the water management committee to be controlled and managed by the business activator that will be more sustainable, because the business activator who will have more responsibility on this work of the operation and maintenance. And he is the initial of the concept design to upgrade on the existing water supply system. And in order to improve this infrastructure, we have to separate into three phases. One, we have to rehabilitate the pipe network, and we have to improve the capacity of the solar power, and also change the tank, as well as to install and or construct the water treatment plant to improve the water quality in this community, as they use the water from the river, which is contaminated. Next, please. So here is the solution to improve on what finding in the community, that we have transport the PVC pipe, which is the HDPE pipe, which is a better quality compared to the PVC one. That this one is more sustainable because it currently to use for 50 years, and During the construction or replace the previous PVC pipe, our community, they also contribute to dig the soil and also bury the pipe. As you can see in the picture, a group of women, they are willing to help in this process with no charge, and they expect to get enough water for their home consumption as well as their garden. And you can see after installation, they can use the water for agriculture as well as for raising their pig. So yes, move next slide, please. And beside repairing or replace the PVC pipe to be HDPE pipe, we also upgrade the solar power system, which is the previous one have capacity only 1.4 kilowatt, and we change to 7.2 kilowatt based on the design that we need to use this solar power to operate for water pump as well as the water treatment plant. So this is the new upgrade that we have installed on the island, which is also include the battery and also inverter. That battery can also use during the rainy time or no sunlight. So we expect to use it more than 8 hours, almost 8 hours per day, that people can probably use the water for the whole day. Next, please. And we also have replaced the broken tank to the new water tank. And we change the solar water pump to ensure that the water has sufficient capacity and also the pressure to supply to each household. The solar water pump have capacity, can pump the water for 10 cubic meter per hour, and one tank of the water supply infrastructure contain 5 cubic meter, that the two tank equal 10 cubic meter. Next, please. So because of this water supply system using the raw water from the river, and because of the Mekong River, it changed the water quality based on the season in the dry and rainy season. And sometimes we cannot predict the water level because of the dam at the upstream. So in order to prevent any illness or sickness happen, we need to improve the water quality. Before, the community, they just want to have enough water for using agriculture or home consumption that easy to access. But after our field assessment and discussion among the team, we want to improve the water quality as well, because we found that people out there, they like to use the water or like to drink the water without treatment. Sometimes they are very busy, or they don't have enough time to boil the water or treat the water. So they drink the water directly, just turn on the tap or take the water from their jar near their home. So it is very risky and probably can affect to their health. So in order to improve the water quality, we have to install or construct the water treatment plant. But before we construct the water treatment plant, we have to take the water from the Mekong River to check the water quality. And this is the prototyping process that our EWB, following the TDA, Technology Development Approach, for prototyping, for simulation and validation of the technology. So there are many design options for water treatment system. Somehow this study, we try to minimize the budget for the cost effectiveness and using the local material like natural sand and gravel. And during the COVID-19 pandemic, our office were closed and locked down in our country as well. So at the time, I have to move the system to do the prototype at my home. And this is a very hard and tough time. And this is the backyard of my home and the kitchen. So I try to do anything that possible to accelerate the process of this project. And yeah, after we measure the flow rate, the quality inlet and outlet of the water, and determine the infiltration rate of the media filter, as well as adding the dosing rate of polyaluminum chloride, we can move to the detailed design in the next slide, please. Yes, based on the data that we did in the prototyping, we got the support from our content to design this water treatment plan. And you see, this is a little bit complicated. And to get the clean water, we have to do the treatment process for sure, which mainly include sedimentation, filtration, and disinfection. So I can briefly describe about this process a little bit. So the feed water will be pumped from the Mekong River by submersible solar pump across the side of the head of the clarifier, and using a coagulation, the feed water will undergo flocculation and coagulation prior to sedimentation within the clarifier, and the clarifier will then overflow across the outlet weir into the media filter, where it will undergo the filtration. And the filter water will then be subject to disinfect while chlorine within the post-filter tank. And following disinfection, the clear water will then transfer to the existing water tower and the new clear water tank, where it will be distributed to community via the gravity within the existing distribution pipe network that we have installed of the PVC pipe. So to have a clean water, we have to follow the multi-barrier approach, which is include the soft water protection, safe water transportation, that we use the the HDPE pipe, and water treatment and safe water storage. We also provide the training to the community as well on how to store water safely. The next slide, please. And for the future scaling up, this is just the pilot project in one community, and we also have the plan to scaling up in another community after we see or evaluate the project that we install in this community. We can scaling up to another area that's similar to a similar issue to this area. So for the future scaling up, we have to do the feasibility study, develop marketing plan, and then design the technical plan to make sure that our water supply system is sustainable and scalable in the context of climate change. Yes, thank you. That's all for my project. Next slide, please. The last one. Thank you.
Thank you very much, Marini. That is a wonderful example of the technical work that you've been doing here in Cambodia. Really appreciate your talk. So we're going to move into the panel discussion now, and we've already received some excellent questions in the Q&A, which we'll start with. And while we're getting people spotlighted, I just was thinking that we'll start with a question that came from Sylvia Davina. And Sylvia's asked about the strategy for maintenance and who's in charge and who covers the cost. That question was directed to Kerry, but I believe that all of the speakers would have something to say about O&M and long-term costs and funding of them. But yeah, if we could just start with Kerry and your reflections on the strategy for maintenance and ongoing costs and how you're thinking of managing them. Thanks so much.
Yeah, thanks, Melinda. And thanks for the question. It's certainly something we get asked often. We have had the benefit of working together with our local stakeholders in Macassar for many years now. So we started off back in the very early days engaging with our community engagement committee members, so representatives from all of the settlements that we work in, together with the Department of Public Works, which is the government department that will look after the operation and maintenance from their perspective. And we got everyone together and we explained the infrastructure, what the operation and maintenance requirements were, and then we did a workshop on where that should sit. So we do have agreement, in principle agreement from the City of Macassar to take over the more technical aspects. So that's monitoring the pressure sewer. And one of the benefits of the smart system is that we can do that together initially. So all the alerts and alarms will come to us, some of my colleagues based in Macassar, and also the Department of Public Works, so that we'll have a transition phase of probably 12 months while we're doing other research where we'll do that monitoring together. And then the more simple maintenance is done by the community, and that's already happening in the demonstration site.
Thank you, Kerry. And Marini, I'm wondering if you could also reflect on the long-term funding of the system and operation and maintenance of the system. Thank you.
Yeah, thank you so much for this question. Yeah, for sure, the water supply system for construction is costly, and we cannot get the benefit or profit from this in the short year. So at least we can say that 5 years to get all the benefit to recover all the expense. And for the long term of this system, we have to have one businessman, or we call one activator, who control the system that is more sustainable for the operation and management. And the system as well, we also got the water tariff. I mean, we have to collect the money from the water user that we give the cost currently. 1 cubic meter equal 2,000 real. That is 0.25 $0.25, yeah, US dollar. That is very cheap. And we will use those budget to improve or upgrade the system. For example, if the pipe broken, we can use that money to fix it. If we want to extend the pipeline to another household, we can also use that money that we get from the water user. So this is the long sustainability. Thank you.
Thank you very much. Now, on the theme of costs, but costs and benefits, of course, we have a question for Emilia. And the question is around how important is it to measure the costs and benefits of nature-based solutions, and how important it is to cost them economically in order to compare with other options. Just wondering if you have some reflections on that. Thank you.
Sure. I mean, I think sometimes, I guess, whereas it's a bit less straightforward, the costing when you're doing a protected area, for instance, as opposed to an engineered solution versus an engineered grey infrastructure. One of the ways in which we are, I suppose, providing benefits to facilitating benefits to communities. So in the Solomon Islands, for instance, where communities now aren't going to log the forest, but are then missing out on logging benefit, but economic benefits from logging. We have partnered with Rainforest Trust, who are essentially paying for the ecosystem service that the forest is providing, and then working on arrangements right now on community benefits, sort of investment opportunities, upgrading schools, roads, hospitals, clinics, things like that. Trying to look at then sort of community benefits that are occurring. In our work in Papua New Guinea, Again, sort of setting up, I think a lot of conservation donors are very interested in, you protect a forest and you get all these benefits, you know, as a nature-based solution, but then also recognizing then the communities then investing in things like gray infrastructure that might not have been an option without in existing conditions. So sort of providing additional levels of infrastructure, I guess, in exchange for protecting areas, and then also them providing resources and training for rangers to be able to patrol areas to make sure that sort of poaching or illegal logging activities aren't occurring. Yeah, so that's, I guess, how we work it out from a conservation perspective. Yeah.
Yeah, thank you very much. I think the theme of your talk about the interconnections between all the elements of the system was really a fantastic way to start this whole session, and is echoed through all the presentations. Thank you, Emilia. And yeah, how you draw that boundary about what you cost into those models is challenging, but you've done a great job of explaining some of those elements that you've incorporated into the model. Now we have a fantastic question from Nuhu Amin, who has asked Emily, what are some challenges to installing and operating the system, the nature-based solutions system? Thanks, Emily.
Thanks. I'll get Kerry to chime in here as well. So Indonesia's a little bit more advanced on the operating side than Fiji, but I'll speak to installing. Access to site has been a really big challenge. Informal settlements are located in places that traditional development has skipped over because it's difficult. It's steep, rocky, flood prone, muddy, all the things that you try not to build in. And then I guess on top of that, they're dynamic. So within the 4 years that we've done our concept through to even the last 12 months, goodness, every time we go back, there's a new house somewhere. So we've allocated places with the community to build infrastructure, but at the same time, we're not telling them they can't build there. So we're working with them, and we're attempting to, I guess, not impose on anybody's livelihoods. So that's been a really big challenge. You have to be adaptable all the time, but at the same time, you need to produce plans and detailed designs. So it's this constant battle, and then also with nature-based solutions, there are different critical elements in design. So you can have a contractor who's very experienced in building concrete walls, and a wetland might seem like a very simple structure, but the levels at which the pipes are set are really important. And you need to be in constant communication with your site supervisors, with your contractors, to make sure that they understand that that is a make or break, and how well your silty clay is compacted on the bottom so that your liner can sit on it and work effectively, and just little things that aren't considered, or they haven't come across necessarily in other construction. But yeah, Kerry, anything on operating?
I think having a mindset of being flexible and adaptable has really been, similarly to Fiji, we've had a lot of changes in our settlements, and our team are constantly out there documenting those changes and then modifying the design. And I assume we'll be doing design all the way through construction as well, because we do, it's really important to adapt. And during COVID was particularly obvious, where families had identified spaces that they don't use that then they needed to use for a small shop or another way to earn money. And so we've done a lot of design around new things that were put in place for them to help them address COVID and lockdowns. So yeah, just flexibility.
Thanks, Kerry. Yeah, look, flexibility, adaptability, common themes in this space, especially when you're talking about utilising nature for part of the solution, which is ever changing as well. But fantastic messages there. A couple of questions have come in, and one is for Ed around risks. But the question is, has Tonga thought through what nature-based solutions might mean in terms of ameliorating the risks? So yeah, that next step of building that really complex picture about the problem and the risks. And what do you think about sort of some of the options to address those risks? Thank you.
Yeah, it's it's a very challenging question. And I think has any government fully thought through their options for nature-based solutions? The answer is probably no. The options, I won't say endless, but there's so many, and picking the right one is usually the biggest challenge and the reason that potentially nothing happens. Because I guess coming back to what our project looked at was all about providing a business case, the baseline data to say, this is how much you're likely going to lose in these areas or for this particular asset. You can go into the database and click on a specific asset and understand that based on the probabilistic assessment we've done, you're likely to lose X number of thousands of dollars per year for this asset or for this area. So therefore, the intention is that you could say, well, if we do invest, $50,000 or $100,000 in a nature-based solution in an area adjacent to this, well, that's going to be able to offset some of these losses. So in terms of the Tongan context, there's, due to the low-lying nature of Nuku'alofa and the surrounds and the lagoon, there is, a lot of opportunity to incorporate nature around the edges of the lagoon, and particularly on the northern coastline. That's very low to reduce, coastal energy. Interestingly, on the south, it's exactly the opposite. It's cliffs, as you can sort of see in my background photo. So there'd be a different approach taken there. So I guess the short answer is no. But hopefully, some of the work we've done will allow the government and the next stage of work, which is the urban planning, to be informed and allow sort of business cases to be developed so that people can invest in nature-based solutions or other resilience-focused investments.
Thank you, Ed. Now we have a question for anyone on the panel who would like to answer this, but I might start with Marini. And it's around considering gender equality and inclusion in your programs and projects. And given that the panel here have implemented very different types of projects, I'm sure that the consideration of inclusion and gender equality inclusion overall might have been quite different. So I'm wondering if, Marini, we could start with you to give any reflections on how that has been considered in your very technical project. Thank you.
Yeah, thank you so much. Regarding to the gender equality or equity or inclusion, we always include in our project. Start from the beginning, we start of the project until we deliver the project. So for the beginning, I refer to the project assessment, I mean the field assessment. So, surprisingly that I went to the field, mostly the person that I met are a woman. And when we invite for the workshop or the meeting, I can say that 90% of the women join the workshop. And I asked why there's mostly the women who join the workshop or the meeting, because they said that their husband working like fishery or another work far from home during the time that we visit, and mostly the women who handle on the housework, and the women who are using the water more than a man. So the husband, they decide that women should join this workshop. And when we connect the water supply system, the husband also asked his wife that whether we should connect the pipe network of the system or not. And I asked why you have to depend on your wife decision, because they said that if his wife decide to connect the pipe network, he will decide to connect as well, because he know that his wife will use this water more than him. And if they connect the pipe network system, it means that his wife will be more easier to access to the water, because before I saw by my eye when I went to the field, the women, they collect the water from the river in a very steep wide slope and carry about 40 liter on their shoulder, yeah, of the water for cooking and washing and everything at home. So this is, I can say that gender always include to our project from the beginning until the end. Yeah, thank you.
Thank you very much, Marini. And yeah, you've explained about those different dimensions in terms of involvement, decision-making, and also end users. I know that the RISE project has certainly had a consideration of gender equality inclusion. Kerry and Emily, did you want to make any comments around that at the moment?
Maybe I'll just jump in quickly, Melita. I mean, interestingly, similar to Marini, we had the same challenges of getting participation of men and youth. We had great participation of women, but we worked hard to get the participation of men in our participatory workshops, which took quite a lot of, careful planning. But I think, what we have the benefit of being part of a much broader research program, and part of that is our Water for Women funded research, which has looked at specifically at participation and Gen Z outcomes. And what they have found is that what's really important is that our teams reflect the diversity of the participants, both in language and culture. And also that there was this, we do household visits one by one to make sure every single household has all of the information and understand the choices that they have. And the research is demonstrating that was one of the most effective approaches to the residents feeling like they were included across, women, men, youth, and, people who were not able to perhaps come to the workshops because they weren't able-bodied in that way. So that's been a really interesting outcome for us.
Thank you. Yeah, very interesting. And thank you also to Manahara Kadaka from IWMI for that question. Now we have our last question. I'm sorry that we had a lot of other questions up our sleeves, but it's great that we've been able to prioritise the ones that have come in from the participants of this webinar. And after Emilia has answered this question, this one's for you, Emilia, I will hand to Leah for a thank you and goodbye. So the question is from Jeremy Collitz from ISF, and he asks, I often hear local government stakeholders suggesting that planting trees around a water source, such as a spring, is a good method for promoting water recharge and protecting from contamination. How likely is it that planting trees or other vegetation in a localised area, for example, immediate vicinity of a water source, would actually make improvements in the yield and quality? And how long would this take? So thank you, Emilia. Any reflections at all about the use of vegetation around protecting those water sources?
Yeah, I mean, I guess there will be a magic number where the amount of trees or buffer all of a sudden starts having filtering capabilities. In like lots of like logging codes of practice and development plans, often the sort of the range that you see for like riparian buffers against water sources is between 50 and 100 meters. It's sort of recommended that development doesn't go encouraged beyond that. So, I mean, I don't think if you plant, 5 meters of trees that you're probably going to get obviously the same benefits. In terms of water recharge, I think, again, there's going to be a magic number, but my sense is just obviously understanding fragmented ecosystems don't function as well. And if you start losing sort of the benefits that you can get from a very fragmented ecosystem. And so I would imagine, particularly with something dealing with the relationship between like evapotranspiration into the atmosphere, and then also sort of encouraging more rainfall to happen and the filtration, you would need larger intact areas than a meter sort of around a stream. But I think, yeah, I don't know the magic number. Obviously, as a conservation organization, we would tend to sort of say, protect your ecosystems first, because in general, ecosystem restoration takes a really long time, and it can be sort of 10 years between when you implement, best practice management on land and start seeing downstream benefits to that, because just it takes a while for trees and vegetation to grow enough that they can stabilize soil, that they have that sort of rechargeability, and just, you know, the hydrodynamics of a system. It takes a while to sort of get things to flow through a system. So yeah, restoration is expensive, and can't cover the same extent of an area as sort of initial protection of an ecosystem. So I hope that can answer it, yes, or provide some insight into that.
I think those are some great messages around the fragmentation and about prevention rather than cure, which we know in other parts of our society, and also, yeah, it's going to be different for every system. But it would be interesting after this session if we, as a broader community of practice, looked into studies that have assessed different options, for instance, and what that kind of what some thresholds might be. But thank you very much to our panel for your fantastic answers to all those questions, and for sharing your knowledge, for sharing your experience with us, and planting lots of seeds in our minds. I'm now going to hand over to Leah Satorio to close the session. And
thank you, Melita, and thank you, Emilia, Ed, Kerry, Emily, and Marini. To hear about your expert knowledge and experience today has been an invaluable learning for us all, and I thank you for sharing with everyone today. Melita and Bronwyn, thank you very much for facilitating with myself on behalf of the Australian WASH Reference Group. And Karen and Danny in the background, I just really wanted to thank you too for answering all our questions and keeping us on track for today's session, so thank you. And for everyone online today, thank you for joining us. And we really hope you've enjoyed this knowledge share on nature-based and other sustainable WASH solutions to climate change. Enjoy the remainder of the Water and WASH Future Symposium. And we look forward to chatting and hearing more of your questions as they come through. So thank you very much. I enjoy the rest of your time during the conference. Thanks. Bye.